Deliverables of Measure Phase and Data Collection Plan. Welcome to the measure phase of our Lean Six Sigma project. This phase is all about making sure we collect accurate, relevant, and consistent data to fully understand the current performance of our process. There are three key deliverables we aim for here. 1. Identifying the CTQ. That's the critical to quality characteristics that directly link to customer expectations. 2. Defining clear operational definitions. This ensures everyone interprets and measures the data in the same way. 3. Building a solid data collection plan, or DCP, which lays out exactly what data to collect, how, when, and by whom. These steps are vital. They help us eliminate ambiguity and ensure that the data we're working with truly reflects what's happening in the process. Ultimately, this sets a strong foundation for effective analysis and sustainable improvement later in the project. Before we dive into the content, let's quickly walk through the agenda for this session. We'll be covering three key topics. 1. Introduction. We'll start by setting the context for why data collection is critical during the measure phase of a Lean Six Sigma project. 2. Identification of CTQ characteristics. Next, we'll explore how to identify the right critical to quality CTQ metrics. These are the measurable factors that define what's important to the customer and what we should focus on. 3. Build a robust DCP. Finally, we'll go step by step through creating a data collection plan. We'll look at its structure, components, and how it ensures clarity, consistency, and reliability in your data. By the end of this session, you'll have a solid foundation to define and implement a DCP effectively in your own project. In this step, we focus on identifying the critical to quality CTQ characteristic for the project, the specific metric that reflects what the customer values the most. Here are the key actions. First, collaborate with stakeholders to define which CTQ metric you'll study. This ensures alignment and avoids misinterpretation later. Next, make sure your acceptance criteria or goal statement is in line with the CTQ you've chosen. If they don't match, your project will lack focus. Choose a CTQ that will help during the analysis phase. It should be quantifiable, trackable, and impactful. Avoid oversimplifying. Don't choose a metric just because it's easy to collect. It must still provide meaningful insight. Lastly, ensure that the CTQ is relevant to the customer's needs. If it doesn't matter to the customer, it shouldn't be a focus of your project. This step is foundational. Get the CTQ wrong, and the rest of your project can veer off course. This slide highlights the fundamental purpose of creating a solid data collection plan, DCP, in Lean Six Sigma. The first and foremost reason is to remove ambiguity. Everyone involved in data collection must be aligned with the same definitions and measurement methods. This eliminates confusion and ensures consistency. Second, a well-structured DCP provides a clear way to measure characteristics. It's not just about collecting data, it's about collecting the right data in the right way. It helps the team identify exactly what needs to be measured. No more guessing or relying on assumptions. We know what we're after. The next point is crucial. A good DCP ensures that regardless of who is measuring, the results are consistent. This speaks to repeatability and reproducibility, both of which are cornerstones of reliable data. Finally, the data we gather must be valuable not only for internal process teams, but also for the customer. If it doesn't serve both purposes, it's likely not worth measuring. In short, the purpose of a DCP is to build clarity, consistency, and customer relevance into your measurement approach. Now that we've identified our CTQ, the next step is to create the Data Collection Plan, DCP. This step ensures that everyone involved in collecting data does it the same way, consistently, accurately, and with no room for interpretation. Here are the key principles to follow. Plan well. Everyone participating in data collection must understand what data to collect, how to collect it, and when. The method must be standardized and repeatable. Eliminate ambiguity. If people interpret data definitions or collection steps differently, you'll end up with inconsistent data. That's a serious risk in analysis. And finally, make sure the operational definition of the CTQ is crystal clear to all. This ensures that no matter who measures, the result is always the same. The goal here is to build a DCP that promotes clarity, consistency, and data integrity, key ingredients for reliable decision-making. As we continue exploring the data collection plan, let's emphasize two important points: planning effort and operational definitions. Firstly, the effort you put into building the DCP should match the complexity of your project. If data collection is intricate or involves multiple teams, invest time in developing a thorough plan. That includes preparing checklists, templates, and even training the people involved. This principle holds true even outside of Six Sigma. Whether you're creating dashboards for departments or reporting performance metrics, the structure and clarity provided by a DCP make your outputs more trustworthy and useful. Now let's move to operational definitions, arguably the most critical part of your DCP. An operational definition is a clear, precise, and agreed-upon explanation of how a particular CTQ metric will be measured. It ensures that everyone involved in measurement does it the same way. There is no room for personal interpretation. Results are reliable and repeatable, regardless of who collects the data. In short, without a strong operational definition, your data lacks consistency, and your analysis becomes questionable. Always take time to define it properly before proceeding. This slide introduces two critical components of a data collection plan: performance standards and specification limits. Let's start with performance standards. These are the expectations or specifications defined by the customer for a specific CTQ characteristic. In the context of a Six Sigma project, these standards must align with the goal statement. They help answer three key questions. What does the customer want? What defines a good product or process? What should be considered a defect? By answering these, the team can clearly understand how the process should perform and where the bar is set. Next, let's talk about specification limits. These limits set the boundaries between acceptable and unacceptable outcomes from the customer's perspective. Even if the customer doesn't formally provide limits, they often exist implicitly based on what is considered a defect. For example, a delivery time over 5 days might not be acceptable to a customer, even if they never wrote that down. That's a specification limit in action. These limits are essential because they help us quantify customer satisfaction and disappointment. So, in summary, defining performance standards and specification limits ensures we don't just collect data, we collect the right data with clear judgment criteria. This slide introduces the concept of defect definition within a data collection plan, DCP, a critical element in the measure phase of a Lean Six Sigma project. Begin by explaining that a defect definition is a clear, objective statement that tells us exactly when an output should be considered defective. In our example, the Y metric is accuracy score per agent per day. The performance standard is 95% accuracy. The defect definition clearly states, if the accuracy score for any agent per day is below 95%, it will be termed as a defect. This provides clarity and removes subjectivity from data classification. It ensures that every data collector or analyst classifies performance consistently. Emphasize the importance of such clarity. Without a solid defect definition, data becomes unreliable. Misinterpretation could lead to incorrect conclusions and poor decisions. Wrap up by reinforcing that the defect definition links the project's Y metric and performance standard to objective measurement, a foundational element for reliable process analysis. Now that we've covered the core components like the operational definition and defect definition, let's look at other critical elements that round out a comprehensive data collection plan, DCP. These elements ensure data consistency, traceability, and usability. 1. Data type. O clearly define if the data is continuous, e.g., time, temperature, or discrete, e.g., number of defects, yes, no. O. This distinction helps in selecting the right analysis methods later. 2. Formula to be used. O. Mention any formulas, e.g., NPS% defect rate, that will be used for deriving metrics. Data items needed. O. List out all required variables to be collected, such as counts, timestamps, or scores. 4th unit of measurement. O. Specify if you are measuring in seconds, minutes, kilograms, percent, etc. 5. Decimal. Precision. O. Mention how many decimal places will be used. It prevents rounding errors and ensures consistency. 6. Measurement equipment. O. Mention any instruments, tools, or software used in measurement. If no equipment is used, state NA. 7. Calibration. Information. O. If equipment is used, document calibration status to ensure reliability. 8. Database / container. O. Specify where the data will be stored, e.g., Excel sheets, databases, cloud storage. 9. Database creation. Date. O. If new storage is being created for this project, note the creation date. 10th. Responsible person. Assign ownership for the data collection process. This improves accountability. 11th. Training required. If data collectors need training, highlight that need. 12th. Operator information. Capture who will actually collect the data. Emphasize, all of these details may seem granular, but they collectively ensure that data is accurate, consistent, and repeatable across time, collectors, and locations. Wrap up by reiterating that a well-documented DCP isn't just about data, it's about control and confidence in the process. This slide presents a Sample Data Collection Plan DCP template, a practical tool that helps organize, standardize, and structure data collection in a Lean Six Sigma project. Let's walk through its key components. Top section. Define the why and its boundaries. Why? This is the project's output metric, the performance measure that reflects the voice, the customer. Operational definition. A precise, unambiguous definition of the metric. It tells everyone exactly what is being measured and how to measure it. Defect. Definition. Clearly states what constitutes a defect for the Y metric. This removes confusion when tagging outcomes as acceptable or defective. Performance standard defines the minimum acceptable level of performance, e.g., greater than or equal to 95% accuracy. Specification limits, the acceptable range, upper and lower limits, that determines satisfaction versus disappointment. Opportunity indicates how many chances there are for a defect to occur in a unit. Critical for calculating metrics like DPMO, defects per million opportunities. Middle section. Mode of collecting data. Data type. Identify whether data is continuous or discrete. Unit of measurement. The measurement scale. Seconds, percent, millimeters, etc. Decimal places. Ensures precision consistency. Database container. Where the data will be stored, e.g., Excel, SQL, SharePoint. Existing, new database. Whether the storage system already exists or needs to be created. Database ready date. If new, when will it be set up for use? Planned start date. When data collection will begin. Bottom section, collection logistics and accountability. Data items needed. Specify what raw inputs or variables will be recorded. Formula to be used. Mention how the Y will be calculated, if applicable. Measurement equipment and calibration. Info. Record any instruments and their calibration schedules to ensure accuracy. Responsibility. Name the persons as responsible for the data collection. Training need. Specify if training is required for data collectors. Operator info. Who will operate the process and/or collect the data. Key message. This DCP template is your foundation for consistent, reliable, and bias-free data collection. Encourage participants to fill this out collaboratively with stakeholders before beginning the measure phase. A well-filled DCP improves data integrity and increases confidence in downstream analysis. This slide summarizes the core learnings from our discussion on building an effective data collection plan, DCP, during the measure phase of a Lean Six Sigma project. Let's walk through each of these 5 critical steps. Step 01. Identify relevant CTQ metrics aligned with customer expectations. Start by pinpointing critical to quality CTQ metrics. These should be directly tied to what matters most to the customer. This step ensures we're focused on improving aspects that deliver real value. Step 2. Define clear operational definitions to eliminate ambiguity. Use precise, measurable terms to define your metrics. This step ensures that everyone interprets the data the same way, removing subjectivity and guesswork from the process. Step 3. Create a robust data collection plan. DCP for consistency and accuracy. Document exactly how, what, when, where, and by whom the data will be collected. A well-structured DCP ensures data integrity and allows for repeatable, reliable measurement. Step 4. Establish performance standards and defect definitions. Set clear expectations for performance, e.g., greater than or equal to 95% accuracy, and define what constitutes a defect, e.g., less than 95% equals defect. This makes your analysis more objective and actionable. Step 5. Ensure everyone involved interprets and collects data uniformly. Train your team and communicate the DCP clearly. Uniform understanding and application of the plan is what makes your data trustworthy and usable for analysis. Final thought. When these 5 steps are followed, the data collected becomes a true reflection of the process, setting a strong foundation for accurate root cause analysis and impactful improvements.